All right, we're on to the next one. Looks like it's non-functional tests with Evo. So Evo, you want to give a rundown of your blueprint here?
Sure. Hi everybody. I guess I'll first quickly introduce myself. I'm I'm a PhD student at UC Santa Cruz, and I'm a summer intern at Red Hat working on the project that I'm going to describe. And I would really appreciate any feedback that you have. I'm going to actually use a slide deck that I prepared for this. I think I can share screen, right? Let me know if you see what I'm seeing.
I see the presentation.
Okay. So the idea is to incorporate non-functional testing for in the Ceph development process. And non-functional testing, it's a word that generates kind of a discussion on what that means. But in general, um, it basically, I mean, from the point of view of integration testing um, and benchmarking, it's kind of a combination of the two. So in integration testing, you go through all these setups of deploying, configuring, and then testing that everything works. In benchmarking, you deploy, configure, and then you benchmark. Non-functional testing, it's the way it's defined, at least by Wikipedia, is testing a requirement that specify criteria that can be used to judge the qualities of a system rather than specific behaviors. Another way to describe this is to um, to to describe it as specifying a statement of the form the system shall be and then a quality. For example, the system shall be scalable, the system shall be performant, and so on. And the main problem with this type of testing, I mean, it's useful in the sense that it's testing a property of the system as a whole. The problem is that it's hard to quantify. How do you know that? How do you quantify precisely in order to determine that your system scales or that your system performs in a certain way? So that's the main problem that we are addressing as part of our research at UC Santa Cruz, and we're trying to apply some of the ideas that we've generated. And so the main goal, or one possible approach that we want to use to address this, is what I mentioned before. It's basically you kind of uh, uh, merge integration testing with benchmark, and by gathering performance metrics, and then on the output of those performance metrics, you take some assertions and validate those assertions on top of that data. You're basically defining tests over the benchmark output data, and then those assertions become a test, and you can think of those as an integration test. So it will fail or it will pass depending on how the output of the benchmark looks like. And there are some challenges. The first one is that the hardware is non-deterministic, of course. But we want to address that, and then the second one is that we need a way to specify these tests. So how do we specify that a system should scale or that a system should be performant or so on? And we plan to address the first one by leveraging Docker. In particular, Docker has I mean, in C groups in particular, C groups has these subsystems, the block.io and the net class subsystems, that allow you to constrain the resources that a container observes from the host machine, and that kind of gives you the ability to among a different set of hardware setups, you can find a lowest common denominator, and then that should be observed everywhere, regardless of what the underlying machine is. So that it's not perfect, but it can work for many cases, and that's one of the things we want to try to see how good it is to use it as a way to bring determinism. And then the second one is that we need a way to specify tests. And in our project, we have a validation language that we come up with, and it's basically having an output file with performance metrics. You can define this type of assertions. If, for example, if you're measuring scalability and you have the cluster size, and then the performance of the raw devices and the performance of Ceph, and whether or not the network is saturated, then you can specify this type of validation statements. And then we have a validation engine that runs that on, and basically it's a yes or no, it's a Boolean function, whether or not the output data complies with that validation statement. So using these two things, Docker on the one hand, and having this validation language on the other, we want to bring non-functional testing to Ceph, and in particular the steps that we need to go through is first we need to deploy Ceph and Docker so that we can configure C groups dynamically, then run benchmarks and validate these assertions over the output of the benchmark. So we're going to focus on Rados initially, so that we can wrap it up in a 3-month in a summer project. And so the particular set of the list of tasks that I'm sorry. So I looked first on how to do this using either tautology or the Ceph benchmarking toolkit, the CBT tool, and there are some pros and cons of using each, but I ended up deciding on using tautology just because there's more people working on it, more eyes looking at it. So our plan is to add a Docker task that is basically leveraging an orchestration framework that's called Maestro. It's a Python framework that orchestrates deployment of Docker multi-host systems. And initially, we would just pull from the Docker registry without having to build the images. And then using these Docker tasks, we would deploy Ceph and configure what are the resources that each container has available to them. Then the Rados benchmark task that it's already there in the Ceph Q&A suite. As far as I know, doesn't write the output to somewhere. I might be wrong, but the idea is to take that and produce a file that we can actually look at the output of the Rados benchmark task. Then also add an AVER task. AVER is our framework, so it will basically a wrapper around AVER that points the Rados benchmark and a validation statement to the output of Rados bench and determines whether or not the validations hold. And then the last thing is to write validation statements for all these properties that we would like to observe. And that's pretty much all the slides that I have. Do you have any question or comments?
So if I understand the point of the last task, which is specify validation statements, the goal of this is to provide tests that say that we're not experiencing performance regression or performance loss. Is that what you're saying?
Exactly. Yes. So you have a particular version, a release And then on a set of the hardware setups, different clusters, you are certain that these properties hold on each of those. So you run a scalability test, and it holds on multiple clusters. And so it's like a new layer of testing. You have unit testing, you have integration testing, and you have now this type of testing that it's more, I would say, more high level. Or yeah. So the idea is to incorporate this as part of the development process. So when you release something, before you release it, you can check that those properties hold and there's nothing that has broken them.
Okay, so then one follow-on question then would be, have we identified, because I would imagine you can't, it would be difficult to cover the thing with a lot of guarantees. What set of validations have we identified as things you want to do as part of this project? So I'm guessing there's some measurements.
Yeah, so the first one would be scalability and performance. Availability is a little bit trickier because then you need to simulate hosts going, OSDs going down and things like that. So I actually haven't thought about availability, how to implement the availability.
Okay.
Benchmark. Because you need a benchmark, right? So we already have a benchmark that, Rados bench, if you just repeat the same benchmark on multiple OSDs configurations, and you have the scalability test, the performance test. Rados benchmark can also be used for that. But for availability, we don't have a corresponding benchmark.
Okay, so does the test focus on a specific part of the benchmark, the whole benchmark?
So it looks at the what do you mean? I'm sorry.
Oh, I guess I'm just trying to understand, like, in the case of Rados bench, it spits out some numbers. Is the test over the entire output, or is it over specific pieces of it? So, like, I guess what I'm looking for is a concrete example. Can you share anything like that?
Yeah, so for example, Rados bench shows you the throughput over time, right? Then you want to observe that throughput not go out of a specific range. You say, okay, the throughput of the system should be within 95% of the raw performance, for example. And the raw performance might be determined by the number of OSDs that you have available times the capability of each, or something like that. Or you can actually run maybe a DD task, distributed DD task that obtains the raw performance. So your validation would be regardless of the size. Actually, this statement is specifying that. So regardless of the size, I won't expect Ceph, the performance of Ceph, the throughput of Ceph, to be within 90% and above of the raw performance when the network. I'm sorry.
Sorry, is that the query project that Aver lets you use?
Yes.
Okay, so it just to drill down on that a little bit, does it take as an input some sort of time series data?
Yes.
Okay,
it's actually implemented on top of. So I have a small parser that translates these statements into SQL, and then so I support anything that talks SQL.
Okay, that makes sense. So one way you could test things like availability is if you have the time series latency and throughput information from Rados bench, and you could correlate that with events like taking an OSD down. By the way, Technology already has machinery for doing all of that in cephmanager.py.
Oh, I see. Cool.
Like it's extensive. Most of our testing involves running a random thrasher in the background that kills OSDs, reboots OSDs, that sort of thing. So there are utility methods for doing that sort of thing. So you could write a task that manually performs a very specific manipulation on the cluster, logs the time at which it happened, and then later you would be able to look at the log before and after that event and verify that the constraints were met. Is that sort of where you're going?
Yes, exactly. Yeah, thanks. Actually, thanks a lot. That's very useful to know that that's already there.
Yeah, I've been thinking about this for a while, actually. As you start doing that, you can ask around in pound-cp and pound-ceph-devel.
Awesome, thanks.
So
Sounds like it's
for
going to be
regression
incredibly valuable.
testing,
I'm sorry?
Sam,
I
you
was saying
can,
this.
you can go
I
ahead.
was saying. I just said this sounds like it's going to be incredibly valuable. A very good thing.
Awesome,
Never mind.
thanks.
So one thing that may be useful regarding regression testing, if you're going down the performance regression testing route, is Ben England wrote just a kind of simple script for going back and doing basically just looking at performance regression between different sets of like data, which I think he just uses JSON as input, but it may be something that you'd be interested in potentially post-processing some of your run data with.
I'm sorry, can you repeat that? I missed the first part.
If you look in the chat window, there's basically just a simple Python script that Ben England wrote. This is what they use for Gluster, actually, for doing their regression testing. It's not real. It's just basically a basic script here, but this is what we'll probably be using for CBT for doing like regression analysis. I don't know if it's useful to you or not, but it might be something that you at least want to look at.
Awesome. I'll look at it. Thank you very much.
So I had a couple other questions.
No worries.
I haven't seen this Aver project before, so I'm guessing that one of the inputs to the is regression concept that must exist somewhere is an expected throughput threshold, right?
So yeah, so
or does it take historical data and build its own test?
No, so the Aver project it doesn't know about, it doesn't understand what you're, if you look at it from the point of view of columns, right? A CSV file and you have columns.
Yeah.
It's only doing numerical.
Okay,
like,
so you have to give it a threshold or a 99th percentile concept.
Exactly.
Yes.
Exactly.
Okay.
Yes.
So I strongly recommend that whatever procedure you use to build those thresholds, those also should be automated. Basically, we would like to be able to point it at a new set of hardware. I know C groups is supposed to remove the hardware dependency, but it won't really. It'll just do it somewhat. It'll make it less noisy, but when we move to new hardware, we'll need to build new thresholds, particularly by going backwards through various versions to get it historical information. So, however that's done might also be packaged up as a Tethology job.
I see.
That would be amazing.
I see. So I see your point. So when you say greater than a number, that number should be dynamic.
Well, not dynamic. It's fine if you push it into a config file somewhere, but the process you use to derive that number should be reproducible.
Okay.
And documented so that we can do it again later on new hardware.
So forever, what's the interface that you use? Can you just pump it CSV files? Is that perfectly acceptable?
Yeah.
Okay.
Yeah.
So
I mean, the only thing. Well, I assume that there's a driver for a SQL driver. This is in Go. This is implemented in Go. So what I'm assuming is that there's a driver for SQL, for CSV that speaks SQL, which I believe there exists something like that. So yeah, so whatever you can plug SQL to will be supported.
Okay, so Aver speaks SQL, and you expect to be able to convert a CSV into a format that your SQL driver can understand.
There's a SQL driver for CSV files.
Right. So you're not saying there will be an actual SQL database into which we stuff these results, which we then query later. You're saying that at the end of the run, you'll just hoover up the CSV file and process it. Okay, cool.
Exactly. Yes.
Is there a GitHub repository for Aver?
Yeah. And one other thing that I'm working on is that would be like a follow-up. So once you have this information, you have information of C groups and how your host looks like. If you have contextual information of a particular run, and then the output, and then you know that it's valid, then when you move to a different setup, you would like to when something breaks, you would like to find the root cause when a
For what it's,
validation
it-
doesn't hold.
so one thing that might be valuable is each Truthology job generates a summary.yaml. So for these, the performance testing ones, you probably also want to dump all the information you possibly can about the hardware and the C group configuration. Is that what you're getting at? So that later on, when you see the failure, you can get as much information as
Yes.
you can.
Yeah. So an open question that we have is, can we actually, without having to run another test, just say, okay, I have a new setup and a hardware setup, and it looks like this. Will my validation break?
I kind of just assume yes. I'm kind of unless C groups are simply much better at constraining I/O throughput than I think they are. There's no way we're going to be able to come up with thresholds that are aggressive enough to actually catch regressions that will be conservative enough not to trip on new hardware.
Okay.
I'm not sure that's a worthwhile design goal. I think the design goal should be to make sure it's transparent and simple to generate new thresholds for new hardware.
Okay.
Sam, I agree.
All right.
What's the license forever?
I think it's BSD. I think.
Oh, right. Just so you know, in addition to Rados Bench, there's a tool called Small IO Bench. I think it's in Ceph Tools. It actually outputs like 1 JSON line per IO, so you can get exact latency information on every single IO. I wrote it because Rados Bench is not very good for this sort of thing. You may want to look into that. That may be less tedious to work with than Rados Bench.
I see. So it's small IO. Small IO.
Yeah, well, I mean, Rados Bench also has other properties that are not attractive. Like it only writes out full objects and then moves on to new objects. It doesn't ever overwrite objects. So it's not a good proxy for RBD, for example. Small IO Bench writes out a large pool of objects, that the size of the number and size you specify, and then performs a pattern of configurable size writes and reads against them. You may find that to be a more flexible tool.
Yeah, cool. Is that on the Q&A
Potentially.
Q&A suite, or?
I think it's in it's in the Ceph project. I think it's in the Ceph Tools package, which is already installed by default in Truthology.
I see.
That is, it's part of the Ceph bundle of stuff. I don't think there's a Rados task for it. I don't think there's a Ceph QA Suite task for it, but that's easy to write. It's just a wrapper.
Okay.
I mean, all the Rados Bench one does is invoke Rados Bench. Not much to it. You'll just copy that file and, you'll restart a cluster on a local machine, work out how the arguments work, and then duplicate that over into the Ceph QA Suite.
Another possibility might be they're actually on the mailing list recently. There's been some discussion about hey, Danny's on about an experimental object store backend for FIO. There's already a librd backend for it, but actually Danny probably can tell us about the other one.
Well, that is also a little different. That doesn't require the full power of Truthology to set up, since it would be a strictly local test. You'd run it strictly against a single block device.
Oh, you're talking about yeah.
No, for Small IO Bench, I'm talking about the Rados one. It's just like it's analogous to Rados Bench in that it performs Rados operations against a Rados cluster.
Yes.
But unlike Rados Bench, it's actually useful for a workload people have ever done. Well, somewhat useful. I guess you're arguing that Rados Bench is useful for emulating the Rados GW workload?
Yes.
Yeah.
Reasonably so. Well,
yeah,
or also
people worried about performance regressions are
itself.
usually. We don't know what that workload looks like.
Yeah.
Anyway.
Yeah. with small IO bench, there were at one point I think I was once concerned about maybe small operation limit, like performance limitations in it, but maybe that's not a problem anymore. I don't remember.
Oh, maybe if there were like CPU limitations, that might be a thing. I didn't think so though.
Yeah.
I thought that was with
remember
the
seeing
object
that
store
once.
variant though. The
It
object
might
store
have been.
variant has a
I don't
lot
remember.
less other overhead per IO, so that sort of thing would show up more. Well, I believe your takeaway from this conversation should be that I might be lying, and you should take what I'm saying with a grain of salt regarding small IO bench. Although you may find it to be a more
maybe,
useful
but-
tool than Rados bench.
Hopefully, we've introduced enough confusion into this to make it interesting.
Well, that's all I have. Thanks a lot for the feedback.
All right.